On this presentation there will be a lot of code, and on some slides the font size is pretty small, so come closer to screens, not to me. There is a big screen, so you can see in that part, and there's another one small screen, and yeah, if you prefer, you can sit here, closer to me, but the screen is smaller here. And I'm not sure you will see the code from the middle part, sorry. Just a reminder, if you have friends who are still in the lobby drinking coffee, let them know that we're about to start. By the way, while we are waiting, how many of you are not from Jordan or don't live here? So just couple hands. Yeah, raise your hands. Who are not from Jordan? Okay. Who is from Jordan? All of you are from Jordan. That's amazing. That's crazy. That's crazy. That's really cool because it means there's a lot of Android developers here in Jordan, and that's really cool that you all came. That's amazing. Let's wait 2 more minutes and we will start. Who entered just now and didn't hear what did I say? There are 2 screens. There will be a lot of code. So just be aware that in that part, there's a big screen. You will see the whole code in that part. And there's also a small screen you can see here, and then you will see the code on the small screen, if you prefer. In the middle it will be harder. On the back seats it will be harder, but it depends on how do you see. One more question. How many of you, not only Android developers, but develop something else? It's around 1/4. What do you develop? I'm just interested. iOS? Raise your hands. Who developed iOS? Just one hand. Just one hand. 2. Backend? Yeah. 2 hands. Competitive platforms. But anyway, it's fun. It's fun. It's fun to develop on many platforms. It's interesting. Okay, let's start. مساء الخير. كيف حالكم؟ كل شيء تمام؟ طيب. Okay. Let's start. I saw that many of you, almost everyone here are from Jordan. Maybe I'm trying to find excuse for me not to speak Arabic, and maybe the excuse is I'm not really good in Arabic. English is much better for me, so I will speak in English. I just started learning Arabic, so excuse me. Yeah. Today I will talk about security mechanism in Android. We will talk about internals of the Android operating system itself. So I'll show you some of the mechanisms that help you write secure and safe apps. And let's start. Just a couple words about me. My name is Anton Dudakov. I'm software engineer at Ziina. I'm mostly experienced in Android, but since I'm working in a startup, I'm writing the code for other platforms. And iOS a lot, and Backend just started, and even touched a couple times Web. Previously, I was working in spare devices, so I'm a little bit familiar on how Android OS works. We've been making custom devices, it's TV dongles, smart speakers, and even TVs. In Yandex, when I was working in Yandex, we were making, I was working in automotive department, we've been doing HeadUnits for cars, so same, it's some custom devices on Android. Also, I am regular host of irregular AndroidDevPodcast, sorry, it's in Russian, and sometimes from time to time I organize meetups in Dubai. Yeah, but what is Ziina? Ziina is a best payment system for business and for personal, and we're looking for some senior backend developer. I saw a couple of hands, let me know if you're interested. Yeah, again, while I was talking about me, you probably forgot what's the topic. The topic is Android security, and I will talk about how Android OS internally helps you to write safe apps, and what Android mechanism internally Android has for the safe environment. We'll have 5 chapters. After each chapter section, I'll be making a small break to answer questions because they're a little bit different. So yeah, after each chapter, I'll let you ask questions and I'll be answering them. And you will have them. So 5 chapters. First is apps isolation, also known as sandbox. How the sandbox works and what is sandbox in Android, how permissions work internally, how system checks permission, and what is multi-user mode and how it's implemented in Android OS. In the 4th chapter, I will touch a little bit as Linux, some enhancement in security for Android, and there will be the last slide. And first things first, but not the first, maybe zeros. So let's start with this. Why do you all need it? Why do you all came to this hall today to listen about Android security and about Android internals, Android OS, some mechanism? Why do you all need it? First of all, just for fun, because you're curious and you want to understand how it works. Just one, because you can. Or maybe you work in some company with a multi-app environment. What does it mean? It means you have many apps in your company and you need them to communicate between each other in a safe manner, in a secure way. Or maybe you have only one app, but you want to provide access to this app to third-party apps, and you want to implement an SDK, and you want to make it secure. Or maybe you're working on your own device. It can be anything. Smart speakers, as Danny said, it can be anything. Smart speakers, HeadUnits for cars, or I don't know, watches, phones, tablets, or even a toaster. Toaster on Android is my dream. Or maybe you work on some custom firmware, and my respect to you if you work on some custom firmware, because it's really hard and it's really interesting, and it helps. Custom firmware brings in new life to some old devices. Okay, let's start with the first chapter. Apps isolation, the sandbox. What is the sandbox? Sandbox consists of 2 parts. First part is a directory. Each app on Android located in its own directory. For example, our app, Ziina, is located in data, com.ziina, and then the package name. It's the app where all the data of our app is located. And only our app has the access to this directory. No other apps has the access. And the access rights for this folder is for user is full access, and for all others, no access at all. But what is user in this context? The user actually is the user under which the app process is running in the system. You can see on this list, this is the list of apps that are running on my phone. It's my personal phone. I list all apps, and each app has its own user. So this is the user under which the app process is running. So only this user has the access to the app folder. Yeah, and you can run it on your phone as well. Connect your phone, ADB shell, and then top will show you all the apps. And it will show you how Instagram works somewhere in the background and consume many of your resources. But if each app runs in its own sandbox under the own user and with the access to its directory, how to make a communication between apps. So there's a way how to make a communication in every operating system. So it's called inter-process communication, IPC. In Android, IPC implemented as a binder. It's a Linux mechanism, pretty old Linux mechanism. And in Android, there are a number of methods to check access rights. What does it mean? I'll show you. So this is one of the easiest way how to share the data, the streaming data from one app to another app. There are many ways, but it's one of them, one of the examples. It's a content provider. In content provider, when you implement your content provider, you can override method open file, and then you return the parcel file descriptor. But how to get this parcel file descriptor? You call static method create pipe, and under the hood create pipe calls the method os.pipe2, and it's a Linux command that creates some pipe, and it returns an array of 2 file descriptors. First one for writing, and second one for reading. When you have this pipe, when you have 2 file descriptors, you return 1 file descriptor to the caller, to the client app, who called the open file, and you can start writing some string from your personal folder, from your secure folder, from your sandbox. You start writing some file or some string to this pipe, and the client starts reading. And how the client starts reading? Yeah. On the content resolver, it opens the file descriptor. It has a file descriptor, and it just reads from this file descriptor some data. That's it. And there are no limitations. You can stream any data, any amount of data through this because it's just a stream. On the diagram, it works in this way. Again, on the content resolver, you call method open file descriptor with the URI to content provider. In the content provider, the server app creates a pipe and shares with the client parcel file descriptor. It's a file descriptor and file descriptor for reading, and the client starts reading from the pipe, and server obviously starts writing to the pipe. Again, os.pipe2 creates these 2 file descriptor, and it's a Linux command. You even can find the manual for this command on Linux man pipe2. That's it. But as I previously said, there are some methods in binder to check permissions of incoming call. There are 2 ways from where we can receive the call. If we have a service, we receive the call from AITL, and if we have a content provider, yeah, we receive the call to the content provider. Let's start with the service. We have some implementation, and there are two methods we can use to check from where we receive the call. And it's two static methods, binder get calling user ID and binder get calling process ID. If you want to know deeper about different ways how to make inter-process communication between apps, you can scan this QR code. It's my another talk that I made, so it's available on YouTube. There are a number of ways of implementing inter-process communication. But you made photos, but I think we will share this presentation. Mohammed, correct me if I'm wrong, but I think we will somewhere we will share presentations. Two methods: get calling UID, get calling PID, to understand from where we receive the call. In content provider, there are some extra things. When we receive some call, we can get calling package. In Kotlin, it's shorter, just calling package, and we can know which package called our method in our content provider. And when we receive a call in content provider, actually we receive it with the permissions of the caller app, of the client app. The client app, when it makes the call and we receive it in our content provider, we have the permissions of that app. So we don't have an access to our own sandbox directory. How to deal with it? There are two methods: clear colon identity and restore colon identity. When we receive the call, we can call clear colon identity, and it switches the permissions to our app, to the server app hosted, which hosts the content provider. And when we call restore colon identity, we obviously restore it to the caller app, to the client app. So once we've done everything, we can return to the client something. What client wants, or not. Here's all the methods that I mentioned, and the interesting thing that all these methods, they use not only in the just apps, but in the operating system as well. Android operating system use the same methods internally. I will show you in the next chapter in the next chapter about permission. But as I said, we can stop if you have questions about the sandbox and apps isolation and about IPC. I can answer a question right now, and because they're a little bit different, all the chapters are a little bit different, so we will have stops after each chapter for answering the questions. Questions?
Okay, I have a question about securing this communication. So we can establish inter-process communication between different apps, but if you have another provider service, how can you authorize another app and say that it is safe to communicate? So for example, we could have some malicious app that says that it has a package which you usually would trust, and then try to extract some data from you. How do you handle this case?
So, it's a good question. I didn't mention it. But it's a valid question. So for this reason, there are permissions, and you can declare custom permissions, and you can even declare permissions with the signature, and you can check the signature permission. If the app calls your app, and you can declare the permission with the signature. So it's some metadata in the permission. When you declare it, you write somewhere in the metadata that it's signature permission. It means that the app that calls you should have the same permission, and it should be signed with the same key like a server app. And it works. You don't need to add any other checks with the calling package or get calling UID, PID. It doesn't matter because it's already done by the system. So no more questions? Great. Let's move on. Permissions. Does anyone know which operating system component is responsible for permission, for storing them, for checking them? Maybe you know, some manager, or some service, or service manager, or managing service. Who thinks? Yes. Which one? Google? Google is a company, but we talk about the internals of Android. So yeah, it's a permission manager. Yeah. So there is a component in the system called permission manager, and it's responsible for all the permissions. So a while ago, for permissions was responsible package manager. Now it's moved, and it stores runtime permissions in this file, runtime-permissions.xml, and yeah, all the permissions stored here. But how this file is used? Let's have a look. Now we will look at one example, how the system checks permissions. We will use as an example location manager, how location manager checks if the app that called get location has a permission to get this location. So let's start. You probably, I think most of you know this method, location manager, get last known location. Easy. Sounds really easy. And under the hood, location manager, when you call get last known location, the location manager has the binder. It's a reference to the service location manager service in the system. And through this binder, when we call get last known location, location manager calls on the binder get last location on the location manager service. And then the call goes through IBC to the system process. Through the binder, it goes to the system process. In the system process, it receives a location manager service. And the first thing that location manager is doing is creating the caller identity. Caller identity is just a kind of a data class with some information about who called the permission. And then it checks the permission. Location permissions, get permission level, and actually it calls almost the same thing, context, check permission, but context that works in the system process. It calls context check permission, and what context is doing? Context calls permission manager. Permission manager check permission, and the permission manager, it's a static class check permission. It calls, it gets the reference to activity manager service, and on the activity manager service, it calls check permission. And the activity manager service, it gets the package manager and calls on the package manager check UID permission. When the call comes to package manager service, it has some computer. It's a service, and it calls on this computer check UID permission. And this permission goes back to package manager, but it's not that package manager service that we called from the start. It's another one. It's a package manager service. It's not just the static method that it was previously. It's a real method on the real service. So yeah, and it calls on permission manager check UID permission. And on this step, you probably will ask, how deep is this rabbit hole? Let's have a look. In permission manager service, it's already found in its state user ID state, and on this UID state, it calls is permission granted. And in these states, it already has all the permissions, and it just checks on the permissions list, is it granted? And this list is cached. It's already cached. So permission manager has all the permissions states all pre-cached. But who fills this cache? Where does it come from? Let's try to find it. And we see that this cache with the permissions, it mostly goes from the method put permission state. So let's have a look who calls the put permission state. Let's rewind this stack, and we see that this stack goes to restore permission state. Now we probably will find how the system fills all the permissions. Restore permission state. Let's find this method. We found this method, and we found that the method restore permission is not responsible for runtime permissions. And yeah, we stuck. So, but who is responsible? How the system fills this cache? What we know that the system stores permissions in file runtime-run permissions.xml. How do I know it? I don't remember already. Just know it. So we can find where this in the source code of Android where this file is declared and how it's used. And we found that this file declared in runtime permissions persistent implementation. And this class is responsible for reading from this file and for storing this and taking all this permission and fill the cache somehow. And on which step? It runs on the step when permission managers, when package manager service runs for the first time. When the main function of the package manager service got called. So we know when the system starts, it runs all its components and the package manager service as well. And when the package manager service starts, it calls the main function. And this in this main function, it reads all the permissions from the file and stores it to the cache. So we found it. And now we probably can answer the question: how deep is the rabbit hole? Yeah, it's pretty deep. It's pretty deep. So if you go into work on permissions in the operating system in Android OS, so my respect. Yeah, and before we move to the multi-user mode, questions about permissions. You can take my mic.
Okay, so the first project you showed us earlier, right, that ended up by getting stuck and finding the actual permissions. So what is, or what was this flow actually used for, that you showed us before going to this class? Is it used for another type of permissions, another thing?
Come again?
So you showed us a flow, right? And then you mentioned that you got stuck at the end of this flow, you couldn't obtain the permission. Yeah, this one. So, and then you showed us a different implementation that writes directly into the cache of the runtime permissions file, right? So, these permissions that I mentioned here, are they related to the application permissions or are they different permissions of some sort? So,
Yeah, this method is not responsible for runtime permission, but this method is responsible for install time permission. Yeah, it's about install time, and the system grants them automatically once they are installed. That's it. It's about install time permissions, but not runtime. For runtime permissions, we need to know this file name and find it in the system. Maybe if you know the better way how to rewind all this stack, yeah, be my guest. Any other questions? No more questions? Okay, then let's move to the next chapter. Multi-user mode. You probably know that your Android phone supports multi-user mode, and you can add more users except your one. Just another user with like on the computer. So with another environment. Yeah, some people use it for different WhatsApp numbers. Yeah, but some of you probably didn't know that it even exists, and maybe who didn't know, probably you didn't know because of the vendor of the phone, and they didn't switch on the multi-user mode. But let's have a look. But Android supports multi-user mode, like the computer, and there are 4.5 user categories. The system user, don't mix with the user system. User with the name system, it's a different one. It's the user, it's a Linux user under which the system works. But system user, it's the main Android user, not the Linux. It's an Android user under which your phone works. So once the phone started, the setup wizard finished, then the phone works on the main user. It's a system user. It's just one user. And all the other users that you will add to your phone will be secondary users, except guest. Guest, it's a separate category of the user. When you add the guest user, and when all its data got deleted on the logout. When the guest logs out, all the data of the guest got deleted, and when the system reboots as well. It can be used for public devices, like if in the hotel you have a TV on Android. When the guest leaves the number, you just need to reboot your TV. That's it, and then all the data will be deleted. So for public devices, it's really useful. Admin, it's a separate user category that you can assign to some apps to administer your devices. As I said, 4.5 user categories can be on Android. No user, it's a special user that is used only on automotive devices. In Android automotive, it's a HeadUnits, it's a multimedia system for cars. And there is a reason. There is a reason to have no user mode, because sometimes you just need to use the device without before a setup wizard. Because in the car, you probably want to use the car with the device, and in the car it can be whether the AC controller or maybe something else, some other controls. So even radio, you should be able to use the radio in your car without going through the whole setup wizard. So for this reason, in the car there can be no user mode. How the data is separated between users? So first of all, I need to say there are two, as I mentioned before, there are two modes: single user mode and multi-user mode on Android. Single user mode, and the mode is set in the compilation time, on the compile time. When the firmware got compiled, it's specified, it's compiled in one of these modes, and then you cannot switch it. Or I'm wrong. Maybe I'm wrong. Please check me. But anyway, in the single user mode, data is not separated, and all the app data is located in the directories that I mentioned before. Data, then the package name, and the data shared between apps. The shared data is located in the folder called SD card. In the multi-user mode, it's a little bit more interesting. The applications data located in folders, in user folders, data user, then the user ID, then the package name. And the storage, each user has its own storage that is publicly available between apps, storage emulated, and then the user ID. And each user has its own media and all the settings. And if you call on the context get data here, your applications directory, it gets the directory from the package info, and the package info gets it from the application info, which is initialized for the specific user when the system starts, when the SDK starts. So it already has pre-cached information about which directory used for data or for something else. Yeah, before we move on to SE Linux, about multi-user mode, questions? About automotive maybe, no user, secondary, access between users, guest mode, No? Yes.
Is there a way to share the data between the users?
It's too expensive.
Perfect. Imagine this case, like me and my friend, we are using the same phone together. I don't know why, maybe we're just don't have enough money for the phones. But we have the user isolations. Yes, I have my folder, he has his own folder. We don't have any intersections. And is there a way to have some shared space where we can store common files that we both need to use? Or it's complete isolation in the Android system?
It's a really interesting question, really interesting. You know why it's really interesting? Because I don't know the answer. You probably can't find the way. You probably can't find the way, and you probably can write the app to share data between users. So the app can understand when it's running in multi-user mode, or the app can prevent running in multi-user mode in secondary users. So I believe there is a way, but I just don't know. I can, just you need to explore in the SDK. I cannot answer it, so I don't know. But anyway, send it through WhatsApp. Use the network. Warm the servers. Any other questions? Okay. There is one additional security system that even restricts the system from doing anything. Not anything, from some things. And this system called SE Linux. It's security enhanced Linux. It was founded by the National Security Agency of USA. And now it's contributed not only by NSA, but also by some tech companies that you see on this slide. This is the most active contributors. And how it works? It's as I said, it's a separate security level, separate security mechanism. Now it's works in the mode deny everything by default, and then you need to set it up to allow for some apps do some things or access some things. And before Android 4.4, it was in the mode login everything, and even before it was allowing everything. So Android got more secured with after 4.4. Which objects SE Linux manipulates? First of all, it's files, access to the files, and it manipulates with the processes. In terms of SE Linux, they call domains, not processes, they call domains in this system. And also it restricts, for processing, it restricts access to the files, access to the network, to opening ports, or even Unix sockets. Unix sockets, if you remember on one of the first slides, there was a pipe command. Pipe command, it's a Unix socket, it opens Unix socket. On which layer does SE Linux work? Let's have a look at an example. When some process asks for some file, first of all, the Linux checks under which user this process works. And it checks, is this user, does this user have an access to this specific file in the Linux security mechanism? If it has, then SE Linux checks if this process, the specific process, SE Linux doesn't know anything about users. It operates with processes. Does this process have an access to the specific file? And it allows or denies. This is an example of SE Linux policies file. It's the example for the DHCP. So DHCP it's one of the networking services, And of course, obviously, it needs to control network file. It needs the access for writing for the network file, and yeah. First, it declares that DHCP is a domain, which remember, a domain is a process. And in the second, I show you it's allow DHCP writing to the proxynet file. Yeah, and also need to say that all these rules compiled at the compile time when the firmware got compiled. It compiles into the binary file, and you cannot change this file in the runtime when the system runs, when the firmware already built. Of course, there are some hacky ways how to do it, but no official ways. Yeah. Questions for the previous chapter, SE Linux? Yes.
I have a slightly off-topic question, if you may. Can I ask?
Yeah.
A slightly off-topic question.
Slightly off topic?
Yeah. I'm seeing here, I'm assuming which language is this? Kotlin, I'm assuming?
This language?
Yeah, the language is before, the slide before.
Slide before.
You're basically showing us in Kotlin, right?
Which slide?
These.
This? Yeah.
These are all Kotlin, right?
No. This is Java. This is Java.
Java.
I took it from SDK written in Java.
My question is, how much control do we have of security in other non-native developers like Flutter and React Native? How much control do we have over security? Things like SE, the Linux layer. There are multiple layers in the security, right? First, check the user, then you check the Linux, the Linux. What was it called?
Yeah, I get the question.
Yeah.
So,
how much do we have control in non-native developers? That's my question.
even as a native developer, you have no control on the Linux checks, and you have no control on the SE Linux checks at all, even as a non-native developer. So if we talk about these checks, yeah, these checks, you don't control them at all. If you build your own firmware, you control them. You need to think about them. If you build your own firmware. For Linux checks, you don't really think about the Linux checks because they're already embedded and they are already done by Google and the Android open source community. So it's already done. It's here. It's a Linux kernel and that's it. It's already here. It's a Linux user system. When we talk about SE Linux, if you build your own custom firmware, it's pain. It's really pain, especially if in your firmware you have some specific devices, some specific ports, or you have some additional services that you wrote, and you probably have services, and you need to have give the access to these services to access some of your custom files. So there is a lot of work for the developers of devices. There is a lot of work for making the SE Linux configuration file. But for the Linux checks, there's almost nothing. But as a developer of the apps, you don't think about it. You just do your work and write the apps. As a native or non-native, it doesn't matter. It's just applications. But as I said on the third, I guess, slide, you probably need it if you do the multiple apps that talk to each other. You need to think about the security, about the IPC, or if you make the SDK for third-party apps.
Thank you.
Any other SE Linux, or off topics?
I have a question regarding the one views. Okay.
And I saw there are two modes of multi-user testing. One where the operating system allows two users, separate users, using the same device. And also allow two users to have access to the same application. So I don't know how this segregation of the users that qualifies for the each application are done for both users. When you, for example, you have two accounts in WhatsApp, say for example, in the same user or under the same mobile application.
Let me repeat how I understood your question. So your question is about how Android allows you to use from two users use the same app without intersections.
No. So for this one, for example, if you go to Samsung version Android, they have secure folder, I guess. It has a different user ID. You have two separate data folders, and basically the folder between secure folder and the actual user. But in some operating system, in some flavors of Android, some Android operating systems you can have two users of the same application, while the application does not allow two users, only allow one user.
I got you. So yeah. Some vendors like Huawei or Samsung, they are all doing it, running one application in so many two instances of the same application with different users. Yeah, it's a nice feature, and it's done by these vendors. It's not from the Android. They made it by themselves.
Using containers. Maybe using containers, right?
What do you mean containers?
Like mixed containers, right?
So which containers?
Like for example, if the folder of the application that the user ID, let's say X, and that is called the Android Y. How they segregate the users? Do you know?
No, I don't know how it's implemented in Huawei and Samsung because it's already not open source. Only Android AOSP open source, but not the vendor implementation. So I'm not sure how they do it, but I can imagine that it's not really hard to run app in two sandboxes. Create the one more sandbox with one ID or with something else. Create a new Linux user for this app and create a new folder for this app and halas. So that's good. Questions before last slide?
I have a general question regarding the Android security. Why the Android devices is always less security than iOS devices like iPhone? Why we cannot reach this level of security? Because it's open source.
I didn't get the question. You mean why they less secure?
Less secure than iOS version.
Why? It's interesting question. Why? Maybe because we just know much more about security breaches in Android than on iOS. Because actually we know cases and we know some companies that really just it's their business hack iOS devices, and it's their business, and they work with some governments and governmental agencies. So probably we just know more. And actually, it's a nice question, especially because of the last slide. Because on the last slide I will talk a little bit roughly about it. So actually, is Android secure? Yeah, as we see, it's secure. and the Linux is secure, and SE Linux is secure, so many security mechanisms are implemented in Android. But, as you asked, but, there are some issues with security in Android, but it's a bad news. But the good news, there's a bug bounty program in Google. If you found some security issues, you can participate in the bug bounty program, like my friend Maxim Bystrykov. He participated, he found an issue, he reported it, and he got money. And he got money for it. So if you found the security issue, you can report it and get money. If it's a small security issue, then less money. If it's a big, then you get more money. So yeah, it's a way to get money. Not even writing apps, but also looking for security issues and reporting them. And not only money, your name also will be in the security bulletin on sourceandroid.com. What else can you read about security in Android? source.android.com/security/features. You can read many interesting things about the security, about signing, about biometry encryption, about some secure element, about Trusty OS. Yes, there is a Trusty OS, additional operating system that runs in the parallel with Android. It's used for DRM, and also about verified boot. It's a bootloader. It also has its own operating system. So yeah, many interesting topics you can read on this site by this link. And if you want to explore the source code of Android, you can either download the full Android source, but to compile it and index it and have an easy way, you need it's preferable to have a Linux machine, but if you don't have Linux, if you're on Mac or on Windows, you can use a website, ces.android.com, where all the sources of the Android located, they index it. It's like a small IDE. You can find anything, you can rewind stack traces, you can literally, like a small IDE with a syntax highlighting. Yeah, really good resource. Yeah, and this is the most last slide. If you still have questions, you can ask them right now. If you want to ask me later, please welcome. There are my contacts.